All right, we're going to skip number 6 and go down to number 7. Okay, so it says if y equals ln of x, solve for x, and then find dy over dx using implicit differentiation. All right, so how can I get rid of that ln? Okay, good. Okay, so that leaves me with e to the y is equal to x, right? So it says solve for x, which we just did. Now find dy over dx. So we need to find the derivative. So what would the derivative be of e to the y? It would be, very good. And then the derivative of x is just 1. That's because you're taking the derivative of a function in terms of y, so you have to include the dy over dx. It's an e to the x function, so its derivative is just the same thing. Now, if I solve for dy over dx, I get 1 over e to the y, right? But what do we know e to the y equals to? X, right? So, all right, so anytime you have the derivative of an ln function, his derivative is just 1 over x. Yep. Now, it's going to be a little different depending if you are taking the ln of, a different function, then you have to use the chain rule, but that's what you get. So derivatives of ln of x and the absolute value of x just become 1 over x. The second one here should be absolute value, but you get the exact same thing. All right. Yeah, I mistyped it. So the x for the second one should be in absolute value. So you just get 1 over x. Now, if you have some type of function that you're taking the ln of, you have to remember that it's going to be 1 over whatever you're taking the ln of times the derivative of the inside. So that's where you have to use chain rule. That's where the u prime comes from. So if I had, like, say, the derivative of ln of 2x, my derivative would be 1 over 2x times the derivative of the inside, which would just be 2. So that simplifies 2 over 2x, which is just 1 over x. Sometimes. A lot of times when you're taking the derivative of the ln, sometimes things will cancel out because it's because you get the reciprocal, which is nice. But not all the time. Okay. So you have the cosine of ln of x, finding the derivative now. All right, so you want to work outside in. So the derivative of cosine would be, all right, keep the inside the same. Now you're going to be taking the derivative of ln of x, which would be what? 1 over x. Right? So your final answer now is what? Over x. Good. All right, second one. You got y equals the ln of 1 plus ln of x. So again, still working outside in. So you have dy over dx. So the derivative of the outside, right, which is the ln part. So his derivative would be what? Good. Times now, you got to take the derivative of the inside part, which would be what? 1 over x. Good. So the derivative of 1 is just 0, right? And then the derivative of ln of x is just 1 over x. All right, now you got 1 over x times 1 plus ln of x. You got 1 over x plus x ln of x. Because again, the x is like built inside of the ln. So when you multiply this and this together, you have to multiply the x by the ln because that's what's on the outside. Because that's the function that you're really multiplying by. You're not multiplying the x times the x. You're multiplying the x with the ln. Kind of like a trig function, where you're multiplying it with like sine, but not what you're taking the sine of. All right, now you could leave it like this, but this is a good thing to bring up. How can I rewrite this? X times the ln of x. Right, good. So we're going to have 1 over x plus ln of x to the x power. Right, so you can take, if you are multiplying the ln with something, what you can do is you can take what you're being multiplied by and put him up as a exponent. X cubed, right? Yep. Yep. It's just a property of natural logs. I'm not too sure. I'm sure there's a reason why, but I don't really know it off the top of my head. I just know that if you're multiplying something like that, you can move that up to the exponent, and then it works the same way. So if you're taking the ln of something raised to an exponent, you can move the exponent out front. So it works both ways. All right, letter C, f of u. You have the ln of the square root of 3u plus 2 over 3u minus 2. All right, this is a good opportunity to bring up some more properties of natural logs. So if you have the ln of x times y, what is that the same thing as? Good. So if you are taking the natural log of something that is being multiplied together, what you can do is separate them two by taking natural log of the first term plus the natural log of the second term, all right? So you can go from this direction to here, or if you have something that looks like this, you can work backwards and multiply them together. You know, depending on your equation, you can use either property. Now, if you have the ln of, say, x divided by y, how can you rewrite that? Good. Okay, so division and subtraction go with each other, and then multiplication and addition go with each other with the natural logs. Right? So sometimes when you are, you know, working out a problem with a natural log, you want to kind of pay attention. Can I, you know, is this going to help me make my problem easier if I use one of these two properties? Yes. Say like the ln of 7 over the ln of 4. Thanks. Not sure. I think you should get the same thing. So let's see. So if I take the ln of 7 over 4, I get 0.559. And then if I take the ln of 7 minus the ln of 4, I get the same thing. So I would probably, I mean, if you saw a problem like that, I mean, I would probably just leave it like that. But usually, like if you have like ln of a, like they wouldn't expect you to know this off the top of your head. So like this would definitely be like a calculator question. Yes. Ln of 7 plus the ln of 4. Yeah. Yeah, you can do that. So whenever you're taking the ln of really anything, it's 1 over whatever you're taking, whatever's inside the parentheses goes in the denominator. Well, this here in blue is the derivative of ln of 1 plus ln of x, right? Again, it's 1 over whatever you're taking the ln of, which is this. So that stays the same. And then multiplying that by, that's the derivative of the parentheses part, which is just 1 over x. Because so u in this case would be 1 plus ln of x, right? And then here is u prime. So it's 1 over u, right, times u prime. All right, so f of u, right, how can I rewrite that? I have the ln of 3u plus 2 over 3u minus 2, right, raised to the 1/2, right? What can I do with that 1/2? Okay. And then how can I rewrite the fraction, the ln of the fraction? Like, what does that turn into? Dante said the ln of your numerator minus the ln of your denominator, right? Because you're taking it's a quotient there, so you can split that up. So you have the ln of 3u plus 2 minus the ln of 3u minus 2. Right, so these two parts stay the same, but I can split the fraction up by using subtraction. Now it's a lot easier to figure out the derivative of. So f prime of u, I have 1/2. So the derivative of ln of 3u plus 2 would be turned into what? Excuse me. 1 over 3u plus 2 times now the derivative of the inside, which is just 3. So you have 3 over 3u plus 2 minus, what is the derivative now of that? Good. 3u minus 2. Yeah. Negative half. So derivative of ln, right, would be 1 over 3u plus 2 times the derivative of the inside, which is just 3. We kind of did like 2 steps in one. Okay, can I take anything out? What do they both have in common? They have 3, right? So I have 3 over 2. Now I have 1 over 3u plus 2 minus 1 over 3u minus 2. All right, what I want to do is I want to try and make that one term. So what would I need to multiply on the top and the bottom so that I can get the same denominator? Three u minus 2, right? So I'm going to multiply this term and this term by 3u minus 2, and then this term and this term by 3u plus 2, right? So that's going to give me 3u minus 2 minus 3u plus 2. Now if I multiply 3u plus 2 and 3u minus 2, what do you get? 9u squared minus 4. Right. Okay. So that leaves me with 3 over 2. 3u minus 3u. So they cancel each other. And then negative 2 minus 2, right, gives me what? 9u squared minus 4. And well, if you, all right, so if you do 3 times negative 4, right, you get negative 12. Negative 12 divided by 2 is negative 6. So that would be your final answer. Well, you could leave it like on the bottom, so you would have like 3 times negative 4 over 2 times 9u squared minus 4. And then when you simplify this, right, then you would have a constant over that constant. Wouldn't really do anything for you. Okay. All right. All right, so so it says number 9, use the change of base formula to find dy over dx. Okay, so change of base. Does anybody remember what that is? So what you can do is you can take the ln of whatever you're taking the log to, right? So that's the ln of x, and you're going to divide that by ln of whatever your base is here. Ln of b. Now, b in this case is a what? Is it a variable or is it a constant? It's a constant, right? So how I could rewrite it is 1 over the ln of the base times the ln of x, right? Because it's technically just a constant, and I can put that out front. Now, when I find its derivative, right, it's almost like the same thing as like like 2x, right? The derivative of 2x would just be 2, right? Just because it's a constant, that doesn't mean it just goes away, right? So when I take the derivative of this term here, the constant's going to come down. And then what's the derivative of ln of x? 1 over x, right? Okay, so your final derivative would be 1 over x times the ln of b. All right, so that is the derivative for any log function, right? So it's going to be 1 over whatever you're taking the log of times the ln of the base that you're taking the log to. All right, so if I had, say the log of 2, say, to the x squared, right? The derivative there would be 1 over, we're taking the log of what? X squared, right? So x squared is going to go in the denominator, times the ln of the base, and what's the base here? 2. And then you just got to remember the chain rule. So what are you taking the log of? X squared, right? So the derivative of x squared would be 2x. Right? So you would have 2x over x squared ln of 2. Right. Yep. And then you could put technically, I guess, the ln of 2 in front. Order doesn't, I guess, really matter. All right, so that is your derivative for a log function. All right, so it's 1 over whatever you're taking the log of, the ln of whatever your base is, and then you just got to remember to take the derivative of the inside part using the chain rule. All right, so log base 3 of 5 minus x to the 4th. So that derivative would be what? Good. Now you got to remember to take the derivative of the inside part, right? Negative 4x cubed. So your final answer would be negative 4x cubed over 5 minus x to the 4th ln of 3. And there's not really any simplifying you can do there. Okay, I got log base 2 of 2 to the sine of x. All right, so you got a couple different functions here. All right, so the derivative of the log function would give you what? Yes. Well, actually, that's a good point. See how our base here is 2, right? And what are we taking the log? What base are we taking the log of? So this exponential here, right? What's the base there? Forget the log part. 2, right? Now, the log function, we're using a base 2, right? So actually, the log base 2 cancels out that 2, and you're just left with sine of x. And then that derivative becomes cosine of x. Right, because this here, the log base 2 and the 2 cancel each other out. So if you have, say, log base 3 of 3 to the something, they would cancel each other out. So these two would have to match up. They have to be the same base. Then you couldn't do that. You'd have to... But we should just practice it just... All right, so let's just practice finding it, because you're going to get the same answer anyway. 2 sine of x. All right, so derivative of the log part, right? Well, if you do it like the long way, you're going to get the same answer. But we can just practice the whole finding the derivative of the log function. Yeah, but it's nice when it cancels out like that. Right. All right, so when you take the log base 2, right, you have 1 over, what are you taking the log of? 2 sine of x, right, times ln of your base, which is 2. Okay. Now we need to take the derivative of 2 sine of x. So what does that become? 2 sine of x times the derivative of your base, which was, or I'm sorry, ln of your base. All right, remember, derivative of a exponential is the exponential times the ln of the base, which in this case would be a, right? So if I'm taking the derivative of just 2 sine of x, his derivative would be 2 sine of x times ln of the base there, which would be 2, times the derivative of the exponent, which is what? Right, good. All right, now if we clean that up, we have 2 sine of x, ln of 2, right? Things cancel, and we're left with cosine of x. Now, if this was the, if we maybe change this to be log base 3 of 2 sine of x, the only difference would be that this would be 1 over 2 sine of x times the ln of 3 times the derivative of that whole thing. So we wouldn't be able to cancel anything if this was base 3. So the only difference would be that this would be the same over 2 sine of x, 2 to the sine of x times the ln of 3. And we would just have to leave it like that. Yeah, you can do that. Right. Yep. That's the, okay, so, right, so if this was like a to the u, right, you'd have a to the u times the ln of the base times the derivative of the exponent. That's what we did right there. Friday.